All right, so yesterday we started looking at sine and cosine, studying some basic properties, like how it looks like a wave, how it's continuous, meaning there's no breaks in it. You can just trace right along forever without lifting your pencil. And we studied the first transformation, which is a phase shift. So phase shift moves the graph left and right. Today, we're going to talk about two transformations, but they're both going to affect the y-axis. Okay? So out of the four, two affect the x, two affect the y. You did one on the x yesterday. Today, we're going to do both on the y. There's a couple things I have to define before we can do the transformations. And that's what's called the height of a sine or cosine wave. Normally, we call it the amplitude. So if you draw out a sine or a cosine wave, the amplitude is measured from what I call the center line. Okay, you put a line right through the center of the wave, and you measure the distance from that line to the peak, which should be symmetric from that line to the low point. Okay, it goes just as far above the line as it does below. That's why it's called the center line. It's right in the center. Okay, and that's the amplitude. So that's the first type of transformation we're going to look at, an amplitude change. Okay, so phase shift, just to kind of summarize what that one looks like, it's y equals sine or cosine, doesn't matter, either trig function of x plus or minus a number. That's what a phase shift looks like. So it's x plus or minus a number. The amplitude change. So amplitude change, a little different. It's when you have a number in front times your trig function, whether it's sine or cosine. So if you wanted to write it like I did the other one, it's a number, and then you have times sine or cosine, and then you plug something in for x. Okay, so here's an example, 3 sine x. That's an amplitude change. -2 cosine x. Now that one's a little different. There's two things happening. The 2 is going to do something. The negative is going to do something. We'll talk about each one separately. Okay, and there's another one, 1/2 sine x. So there's really 3 things that can happen with an amplitude change. You can stretch it taller. You can compress it, make it shorter. And then the negative will cause the graph to flip. Okay, and we'll do an example with the negative. All right, so now if I give you any one of these equations, okay, something I might ask you, or I will ask you to do on the test, is to tell me the amplitude. Okay, you don't have to graph it, you just have to tell me the amplitude. If I want to know the amplitude of any of those equations, you take the absolute value of the number in front. Okay, the reason we take the absolute value, amplitude is a height. Height is a distance. You can't have a negative height. Okay, so it wouldn't make sense to say the amplitude of this one in the middle is -2. It's not -2 units tall. It's 2 units tall. It might be flipped, but it's still 2 units tall. So amplitude has to be a positive number. Okay, so let's actually take the 3 that we have up above and go through and find the amplitude of all 3 of them. Okay, so amplitude. Brady, what's the amplitude of the first one?
3.
Yep. amplitude is 3. Okay, the second one, kind of gave that one away already, but Abby, what's the amplitude of the second one?
2.
It's 2. And Lauren, what about the amplitude of the third one? A half. What if I did that? It would still be a half. So putting a negative in front has no effect on the amplitude. Does it have an effect on the picture when you draw it? Yes. Okay, the negative will cause the picture to change, but it doesn't have any effect on the amplitude. Okay? So it's very important you do not ignore the negative when you do the sketch. But you can ignore the negative if all I'm asking for is what is the amplitude. In fact, you have to. The amplitude is always positive. Okay. Any questions on that? All right, so I told you there's really 2 ways we can transform it if you don't count flipping it. You can stretch it or you can compress it. Does anyone have a guess what kind of number you would have to have in front that would cause it to stretch? How about Jordan? Guess what kind of number would cause the graph to get bigger? Take a guess and say anything you want and I'll try it and we'll see what happens. So we'll compare whatever you say to the original.
2.
2. All right, let's try 2. So 2 sine x. So the one in red is the one we're going to focus on. Okay, so that's the original. Okay, did 2 make it bigger? Did it stretch it bigger? Yes, it did. So 2 is a number that would stretch it bigger. Anyone have an idea in general of what kind of numbers would stretch it bigger? Yeah.
Any number higher than 1.
Any number higher than 1. Yep. So any number bigger than 1 would cause it to stretch bigger. Numbers less than 1 but more than 0, okay, fractions, would make it smaller. So if you did like 0.5, now you could do 0.52, but okay, 0.5 is going to cause the graph to be half as tall. If you throw a negative in there, let me take y3 and just do it as a negative. Okay, so what you're going to see now, the red and the black one are negatives of each other. Exact same amplitude. All that happened is the red one was flipped. So the high point in the red one became the low point in the black one, and vice versa. It flipped over. Now, if you were, let me get rid of the one in blue for a second. If you were just looking at that, and I said to you, how did I change the graph in red to the graph in black? You could say, well, you flipped it. Or you could say you did a phase shift. You really can't tell by looking at the picture. I could take the graph in red and slide it 180 degrees in either direction, either left or right, and get the other one. So let me just show you. Let's do sine of x plus pi. This graph, and I got to put the 0.5 in there. This graph is going to look exactly the same as one of the other ones. So there's the graph in blue, the graph in red. It's going to look the same as the one in black. I don't know if you can tell, but it's tracing over it, and it made it black. So the point is you can get the same picture doing different things. Blue and black are the exact same picture. One's a phase shift, one's a flip. So if you use an absolute value of absolute value of A is greater than 1, it will stretch. Even if A is -5, it will stretch. But it's going to do 2 things. It's going to stretch and flip. So any number that has an absolute value bigger than 1 stretches. Less than 1 compresses. And we are stretching and compressing along the y-axis. Let's just put something in a little simpler. Let's do sine and 2 sine. Okay. If those two waves represented sounds, how do you think the red wave would sound compared to the blue wave? Yeah?
High pitch.
So the pitch, okay, so we think a higher pitch. Any other thoughts? Could be a higher pitch? Yep.
Louder.
Or louder. It's going to be one of those two. And we'll look at it right now. Let's see what happens. So what I need to do is I'm just going to lock both channels together for the volume. So the left and the right channel are going to go up and down at the same volume. And watch as it goes up and down. Louder, and it gets softer. So it is a change in volume. To have the pitch change, we'd have to do something a little different, and we're going to talk about that tomorrow. So changing the pitch is a stretching and compressing, just like changing the volume, but it's not stretching and compressing vertically to change the pitch. It's the other way. It's horizontal. And then when we start changing pitches and frequencies, we can do some really interesting stuff. Not super interesting changing the volume. Change the volume. That's about it. Okay, so what I would probably do at some point, if you're going to make a reference sheet, I would have all 4 of these in the same spot, and I would have this kind of stuff written so you know what to look for. Phase shift, amplitude change. We're also going to do a vertical shift. And then the last one we do tomorrow is a period change. That's the one where the frequency changes. All right, so we're stretching and compressing on the y-axis. So if we stretch and compress on the y-axis, Ryan, what variable is not going to change? The x. So the x's stay the same. And whenever you have a transformation where the x's stay the same, that's great. Because the x's are the ones that are hard to work with. Those are the pi's with fractions. You're not going to have to work with any fractions with pi in them today. So for every single problem we do in the homework today, every single problem we do in class, here's the answer to the x's. 0, pi over 2, pi, 3 pi over 2, 2 pi. That will not change for every problem today. All right, so if the x's are going to stay the same, then the y's are going to change. But remember, the y's are easy to work with. The y's are just 1s, -1s, and 0s. So all you have to do today is arithmetic with one of the 3 numbers I just said. Very, very easy arithmetic. So to find the new y values, you're going to multiply the old y values by a. Notice I did not write absolute value of a. Whatever the number is in front, that's what you use, including if a negative is there, because the negative is very important when you sketch it. So just use the number the way it is in front if you're making a sketch. Don't change it. Okay. Any questions on the 2 steps to do an amplitude change? One thing, when we talk about sound, I can say here that the sound in red would be louder than the sound in blue, but just because it has twice the height doesn't necessarily mean it would be twice as loud. Okay, that sound gets a little bit complicated. Sound is measured in decibels. And we'd have to double check and see if you double the height of the wave, does that really double the volume? It might depend on what kind of tool you're using to graph it. Usually you use what's called an oscilloscope to graph sound. But we're not really going to get into how loud sound can be. Okay, so let's take a look at y equals 3 cosine x. Okay, now we know multiple transformations. We know a phase shift. We know an amplitude change. We have to decide which one this is. Right, so Emma, is this a phase shift or an amplitude change? And how do you know?
It's amplitude.
Yep, I agree. It's definitely an amplitude change. And besides the fact that's what I'm teaching right now, why is it an amplitude change?
Because the number is before the cosine x.
Yep, the number comes before and we are multiplying. If I don't write this down, but if I did this, that's what we're going to do next. Okay? If there's a number on the outside and it's added or subtracted, that's a little different. This is a number on the outside and it is multiplied. Okay. Okay, so we just said amplitude change, x's stay the same. 0, pi over 2, pi, 3 pi over 2, 2 pi. Jamichael, do you remember what my y's are for cosine? Not the new ones, the originals.
Were they 1, 0, -1, 0, 1?
Yep. So he read the correct table. Make sure you get them from cosine, not sine for this problem. So there's my y values. And Luke, what am I going to do to all those y values?
Add the 3. What?
Nope, we're not. I like the 3. We're going to do something with 3, but we are not adding or subtracting. Jim? We're multiplying. Okay. Multiply all the old y values by the number in front. We are going to add a number to the y values. That's going to be the next thing we do. That's going to have to do with a shift. Okay, but this is a stretch. So times 3 on all of them. Okay, so if I multiply all those by 3, Pacey, what do I get?
3, 0, -3, 0, 3.
Yep. There's my y values. Just like the problems yesterday, 5 points for the x's, 5 for the y's. Okay. Now let's do our sketch. Okay. As I said earlier, every x-axis is going to be labeled exactly the same today. You can put 0, but I know the axis is 0. You don't have to label that one. Pi over 2, pi, 3 pi over 2, 2 pi. If you don't label the x-axis, I'm going to assume you're going by ones. 1, 2, 3, 4, 5. Okay? And we are not going by ones here. So you got to put in your labels. The highest is 3, and the lowest is -3. That's a little different from yesterday. Okay? Look at your y column, 3 and -3. Now we can do our sketch. So we can put 0, 3, pi over 2, 0, -3, 0, back to 3. And there's my sketch. Same deal, you're going to have on the homework, there'll be a grid for you so you can graph it a little more accurately, and on the test as well. Any questions on that one? Now, you might start to notice a pattern that every single cosine graph I draw for this section, this part of the section, is going to look the same. The reason is I'm going to change my scale. If you wanted me to graph 7 cosine x, instead of 3 cosine x, I would draw the exact same picture. The only thing I would change is that. Now you have a picture of 7 cosine x. So all my graph pictures are going to look the same. I'm going to change my scale. Okay. If you don't want to do it that way, that's fine. But if you want me to graph something like 7, it's going to be huge. Okay, I'm going to probably not have enough room on the screen to do it. That's why I changed my scale.
So technically, do we even need to do those steps? Or can we just write whatever comes before the cosine and do the same, you know, like graph?
Well, the graph is one, yeah, the graph is the second part, but I do want to see the table. So the table, I mean, if you skip all the graphs on the test and there's like 5 graphs, you're only going to lose 10 points. Because each graph is only worth 2. If you skip all the tables, and there were 5 problems with tables, you lose 50 points. Because the tables are 10 points each. Yeah. So I'm actually more concerned with, can you figure out the coordinates than can you actually draw the picture? Okay. It's good that you can draw the picture, but the table's more important. Okay. All right, so any questions on that one? All right, so let's try one with sine. So 1/2 sine x. Okay, before I sketch it, if you compare this to the regular sine function, is it going to be taller or is it going to be compressed shorter? What's going to happen here? Yeah? Yeah, it's going to compress. It's going to be half the height as the original. Now, are you necessarily going to see that the way I'm going to sketch it? No, because I'm going to change my scale. Okay, so x values stay the same. Tiana, can you remind me what my x values are?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Yep. So there's my x's. Now I need my original y values for sine, so I have something to do some arithmetic with. Ben, what are my original y values for sine?
0, 1, 0, -1, 0.
Yep, perfect. 0, 1, 0, -1, 0. And Austin, I'm going to take all those values and multiply them by
0.5.
0.5. Yep, 1/2. Okay, so Kyle, if I do that out, what do I get for y values?
0, 1/2, 0, -1/2, 0.
Yep. And that's it. So as far as arithmetic, I think this is an easier transformation to do than we did yesterday. Good. Any questions on the table? All right. So now just label your axis and then graph it. So you got pi over 2, pi, 3 pi over 2, 2 pi. And I should probably move those down just a little bit. My y values are, the highest is 1/2, the lowest is -1/2. So that's how I'm going to scale it. You can scale it any way you want, as long as you're consistent, which in this case means it's like symmetrical. 1/2, -1/2. All right, so we got 0, 0, pi over 2 1/2, pi 0, 3 pi over 2 -1/2, 2 pi, comma 0. Now, I looked at that because sometimes when I'm off to the side on the board, my perspective, it's a little hard to see. Now, if I were to sketch that, I can tell that there's 4 points that are nicely spaced and there's one that's way far off. So my graph would look like that, and I can tell something just looks wrong. Okay, so double check that you put your dot in the right spot. If it doesn't look nicely spaced, it's probably wrong. That looks much better to me. Okay, but again, my perspective is off a little sometimes. Okay, so any questions on that one? Right, so we did a stretch with cosine, we did a compression with sine. Let's look at one more, and then we'll do our last transformation for today. All right, so this one is y equals negative cosine x. Now, even though there's no number in front, technically there is a number in front. What number is in front of cosine? Even though we don't see it, yeah? There's a -1. So now, if I just ask, what is the amplitude of that graph? What would you tell me? What's the amplitude of that, Jordan?
1.
1. So technically, there's no change in the amplitude here. The amplitude, if you don't change it, is 1. The amplitude of this one is 1. So amplitude isn't changing, but the negative is going to do something. But it's not going to change the amplitude. So let's see what happens. So x's stay the same. My original y values, we've already done cosine, so I'll just put them out here. And Lexi, what am I going to multiply all these y values by?
-1.
Yeah, they're all just going to get made the opposite. So -1, 0, 1, 0, -1. Okay. So let's graph it and let's see what happens. Pi over 2, pi, 3 pi over 2, 2 pi. Now, technically, you do not have to label your y-axis on this one. How come I would be okay if you didn't label the y-axis? Yep.
Because you're going to assume it's 1.
Because I'm going to assume it's 1, and that's what you want here. You're going to go by ones. If you want to label it, that's okay too. Either way. Okay, so now graph it. -1, 0, 1, 0, -1. So that's part of the wave. It's just the upward part. So try to make it look curved if you can. And it would continue on. You don't have to drive continuing onward. Right, so compared to the original, this graph, what did it do? It flipped. Okay, it took the graph and it flipped over. So technically not an amplitude change, but we can still treat it as the same kind of problem because it falls into the category where you have a number in front and it's multiplied. Okay, so any questions on amplitude change? All right, so I said the other transformation we're going to do today also affects the y-axis, and that's a vertical shift. Again, very easy transformation to do because we're going to be affecting the y values again. So you're going to have to do arithmetic with a 1, a -1, and a 0. So vertical shift has the form y equals sine of x plus or minus a number. So if you're making a list or you're continuing that list that I had before of what they look like, you could put y equals sine or cosine, either one, of x plus or minus a number. Now, if you're wondering, where am I getting these letters from? Like, why did I use D here? And I think before I used A. Well, there's a reason why I use D for this one, but you really don't have to worry about it. It's because if you were doing all 4 transformations in the same problem, this would always be the last one to do. D. A, B, C, D. So if I use those letters, it just makes sense, which it helps you remember the order to do them in. The A really is, I just used A to represent amplitude. That's why I picked A here. Not because it's the first one, but you guys don't have to worry about the order. Okay, so if you don't want to use D, use any letter you want.
Oh, I was going to ask if like the A was supposed to be a C.
Technically, amplitude would be the third one you would do. Yeah, if you were doing these in order, shape phase shift is always the first one you do. The second one is period change, which I haven't taught you yet. The third one is amplitude change. And the fourth one is the one I'm teaching you right now, vertical shift. If you ever do all four in the same problem, that's the order you do them in. So no, the A just stands for amplitude. So I'm not really being consistent with my letters, but again, you guys don't have to worry about it. So. All right. So there's an example of a vertical shift. Sine of x plus 2. Cosine of x minus 3. One of those shifts up, one of them shifts down. Now, you could also do something like this. That's the same thing. Addition is commutative. If you want to add two things together, it does not matter what order you add them in. 6 plus 2, 2 plus 6. Same thing. The point is, if you add or subtract outside parentheses, it's a vertical shift. And if you're thinking, well, what if I put parentheses here? Nope, still a vertical shift. What if I put parentheses here? Nope, still a vertical shift. For it to be a phase shift, you would have to do this. That is a phase shift, because now you've added the x and the number together in parentheses. But if the x and the number are not grouped together in parentheses, it is a vertical shift. Any questions on that? All right. So, anyone have a guess which one is going to move up and which one is going to move down? Is the plus going to move up, or is it going to move down? Oh, Marisha, what do you think? Well, you got a 50-50 shot. Take a guess.
Plus moves up.
Right, so you would think if you're using common sense that plus up minus down, because it's the way we label it on the y-axis. But if you think the way we did on Monday with phase shifts, we had to do the opposite. So now it's a question, do you do the opposite, or do you do what common sense would say? Okay, let's try it. So let's do sine of x and sine of x plus 2. That's the original. And that's the new one. So it is more of a common sense thing. Plus will shift up, minus will shift down. I cannot demonstrate that one with sound because there's really no connection that I can use this program for. Okay, so shift up if you're adding, down if you're subtracting. And Ryan, if I'm going to be shifting up and down, which values are going to be changed by shifting up and down?
Y.
The y's are going to change. So the x's are going to stay the same. So when you're looking at how do you find your new table, x's stay the same. So just copy them down. Okay, if the x's are going to stay the same, there's only one thing that can change. That's the y's. So to find the new y values, you add or subtract d, which is whatever is on the end of the equation. Like in this case, it's plus 2. In that case, it's minus 3. Add or subtract d to all the original values. Don't do the opposite. This is not phase shift. 90% of the mistakes on this problem on the test will be one of two things. People will accidentally treat this as a phase shift, or if they remember to treat it as a vertical shift, for some reason, they'll do the opposite. And instead of shifting it the way they should, they go the opposite way. Okay? I'm telling you, it's not a phase shift, and don't do the opposite. If it's plus, shift it up. If it's minus, shift it down. Okay, again, you don't have to be as concerned about the order, but that is the order you do them in. Okay, does everyone have the steps? 2 steps. Okay, so let's try this one. Sine of x plus 2. Okay, so now we know 3 transformations. We know phase shift, we know amplitude change, we know vertical shift. We have to identify which one that one is. So Ethan, can you tell me what transformation that is? And then I'm more interested in why is that.
This is a phase.
Okay, why do you think it's a phase?
Because it has the like x plus 2.
All right, so he thinks it's a phase because we have x plus 2. Anyone have any thought on what he said, or if you agree with him, tell me that too. I'm just whatever you're thinking, as long as it's appropriate.
I think it's vertical
You think it's a vertical? Okay, how come?
because it has x plus 2 but it's minus x.
Exactly, it has an x plus 2, but the x and the number are not grouped together. For it to be a phase shift, okay, if I just go back to what we had right here, for a phase shift, the x and the number have to be grouped together. Okay, in this case, they're not. The number is outside, not grouped with the x. Okay, so I agree with Emma. It is a vertical shift. Okay, so let's fill in our table. Vertical shift. Lauren, what values stay the same?
The
X's.
x's.
Hopefully by now you're starting to memorize those basic X's. Okay, my Y's. Brady, what are my Y's for sine? Just the originals.
0, 1, 0, -1, 0.
Yep. 0, 1, 0, -1, 0. And Abby, what am I going to do to those Y values?
You add 2.
Perfect. She added 2. She didn't do the opposite. Okay, so plus 2. And Caitlin, can you tell me what I get if I plus 2 to all of them?
2, 3, 2, 1, 2.
Okay. 2, 3, 2, 1, 2. All right. Any questions on that? Okay. We'll make our sketch. It's okay to put the labels close up to the line because the graph is going to be shifted up, so you're not going to end up drawing over them. Okay. And again, this would be a problem. I wouldn't take anything off if you didn't label because I'm going to go by ones anyway. 1, 2, 3. All right, so we've got 0, 2, pi over 2, 3. Pi, we're back at 2. 3 pi, -1, back to 2. And there's our graph. Any questions on the sketch? What's the amplitude of that graph? Yeah.
3.
I would say 3 is the highest value it ever hits, but not the amplitude. but 3 is the highest value it hits. Joe? The amplitude is 1. Remember, if you put in that center line, it's the distance off that center line, either above it or below it. Okay? Another way, amplitude is the absolute value of the number in front. The number in front is 1, absolute value is 1. Questions on that? All right. So why don't you guys take a minute and see if you can do that problem. So cosine x in parentheses minus 5. Okay, I will tell you that if you get rid of the parentheses, it changes nothing about the problem. It would still be the same problem. Okay, so quick fix on the last problem. I didn't mean to put 0 there. We always put 0 on the axis. Okay, don't ever do what I just did. Keep 0 on the axis, and if you don't even want to label the 0, that's fine. And I kind of looked at that quickly, and I was like, why does the first part look more spaced out and the second part doesn't? It's because my point was off by 1. Okay, I did that earlier, and I caught it. This time, I looked at it, and I just kind of ignored it. But just to fix it, this point should be there. That point should be there, there, and there. That looks a lot better. Okay, so always keep 0 on the axis. And as far as accidentally skipping a point, I don't think you guys will have that problem because you have a grid, so you'll be able to see it better than just having like a blank piece of paper. You guys got it? Okay, so when I start to set up my table, which column can I fill in right away? It doesn't change. Yeah, X's. This time, how about Justin? Can you tell me what my X's are?
0, pi over 2, pi, pi over 2, pi.
Yep. So 0, pi over 2 pi, 3 pi over 2, 2 pi. My Y's, okay, the originals. 1, 0, negative 1, 0, 1. You don't have to write those if you don't want to. All I'm going to be grading is what's in that box. Okay. So we're going to take all the old y values, and what am I going to do to them? I'm going to subtract 5. So we've got 1 minus 5, negative 4. 0 minus 5 is negative 5. Negative 1 minus 5 is negative 6. Negative 5, negative 4. Questions on that? Okay, let's make our graph. Really, I only drew graph in the negative quadrant because all my y values are negative, so I don't need to label anything positive. And I've got a grid this time, so it shouldn't be an issue with skipping things, but we'll see. So pi over 2. That's 0. 0 is always on the axis. Pi. 3 pi over 2. 2 pi. All right. So we got 0, negative 4. Pi over 2 is negative 5. Pi is negative 6. Negative 5. And back to negative 4. That looks pretty good. And there's our sketch. Now, I haven't really been saying this a lot, but remember, this graph goes on forever. So that's just one section of it. You could copy and paste what I just drew if you wanted to get another section, because the graph looks exactly the same in every section. It just repeats itself. You don't have to draw another section. I'm just showing you. Okay. Any questions on that? Great. So homework tonight, same as we did last night, be a worksheet. Again, I'll put it at the end of the video in case you need it. We have one section left, So whatever the next day we have classes, we'll do the last transformation. If we have time, we'll have a review day this week. If not, we'll plan on test on Friday.